Well, good afternoon, everybody. Today we're going to be talking about the SCIP system, structural concrete insulated panels. My name is Ismael Vasquez. I'm the technical sales manager for Carmelo and also for the structural panels GCT. Um, uh, our company, Structural Panel GCT, is located in Long Beach, Mississippi. GCT stands for Gulf Concrete Technology. That's where we manufacture the panels, and we also manufacture there the mortars, structural mortars, and also the finished mortars, as well as other material or cementitious products we make there. And we also have a mortar plant in Puerto Rico, and that's where our main offices are. And we have our engineering offices there as well. We also have labs in Mississippi and also in Puerto Rico. Uh, so, um, so let's get going. I was waiting for Scott Miller, but I think he has a situation today. But I'll be leading this meeting today. Also on the line, we have engineer Victor Camacho. He's our vice president for sales and operation. So, any questions that I won't be able to answer, he can also help out as well. So let's get going. Um, uh, our company has been in the business since 2010 with the SCIP system, and but this technology has been out there. It started all in Italy, back there in Europe, over 40 years ago, and right now we have a lot of projects all around the world, and so with our plant since 2010, we have been doing a lot of projects in Florida to up to California, Puerto Rico, and the Caribbean as well. Uh, and the good thing is, our system has resisted a lot of hurricanes. Even Hurricane Maria, we here in Puerto Rico back in 2017, we had structures already built, and in that side of the island, we resisted a lot of wind, over 200 miles per hour, and those buildings are still there. Um, our system again is the only skip technology out there where it meets the building code for the U.S. and also for Puerto Rico. Um, and one of the neat things it has for this system is that it has the R value installation. We go from 12 to, let's say, 36 R value. So the higher the R value, the cooler that building is going to be. Um, so we comply with the building code, the Florida building code as well. And we have a technical evaluation report that we can send out to the designers or let's say our engineers and architects who want to design with this system. We have that manual and digital, and we can, if you send us your email, we can provide you one as well. This is our second. Let's talk about SCIP. So we did talk a little bit in more details on the technical evaluation report. So today what we're going to do is we're going to speak a little bit more about how do we construct these buildings, right? How do we put them together? Um, and again, we comply with many testings. We did a lot of testing for hurricanes, for seismic event up there in the States as well. We took it to the labs with DRJ, and so we put all those testing together, and we comply with the International Building Code for the residential code as well. So we have done residential, commercial, industrial buildings you can use these system in, and the great thing is so far so good, right? We have not seen any damages to these buildings after hurricanes right now, and uh, and again, because these systems are lighter than let's say regular structures, like you can say up to 40% lighter, um, and so and again they're more environmental friendly because again you have less let's say time working with the building, so you can really construct this real easy and fast, right? So on the left side here is these would be our panels, right? How it would look, and again, you can see how things are reinforced between the walls and also the roof and how we connect. We do those connections, but again, we first start with a foundation, right? A regular concrete foundation, and then we use our dowels to let's say join those walls, and then we have connections of L shapes and meshes to do those connections. So your building is going to look like the one in the right, just a regular concrete building. And again, it has you can do different finishes. Let's say like stucco or mortar is, or and there's different types of finishes you can do on these buildings as well. So so again, this construction is going to be real fast. I mean, uh, you in between two people, you can carry these panels. You don't need any like cranes. But we have we recent, but in recently, let's say we've seen that people also want to do it precast as well. You can use forms with it as well, and you can also do precast. Uh, let's say members with these panels as well. So we can do precast, we can do cast in place, or you just can go to our traditional putting the panels first and then spraying the mortar on it. Okay, so so again, we say this is less labor intensive because if you let's say you use you can put let's say these panels like in a minute. I mean these panels come in 4 feet by let's say 8 feet to 20 feet high, and they weigh let's say about a pound. So between two people, they can carry it and place it on that floor. So so again, this provides a very safe area where you don't need heavy equipment, um, and uh, and you can also place a lot of square footage. I mean, by the time you got two people putting, let's say, 300 blocks, we that would be like 265 square foot. We can put, let's say, 1,000 to 2,000 square foot of this material. And that's the advantages of that doing that. So again, what's the difference between the traditional to these panels? That again, these panels are very light to carry, and also they have this already insulated foam that you just place, and then you have that steel, which is galvanized steel, high tension, about 95 KSI, and you already have that there from the factory. And then you can carry it. I mean, usually we want to put one panel at a time, not three like we see here in the let's see on the screen here. And then you can also do it with different forms. We have done rounded shapes, square shapes. So they can be bent as well on the field, and so you can do different shapes there as well. These structure are in the let's say on the let's say southeast side of Puerto Rico. This is where the Maria entered with almost 200 miles per hour wind, and they are still intact there, as you see them. So the first thing you have to do is you have to do your concrete foundation. You have to order your concrete from your local ready mix producer. But first, you do your foundations. You open up the soil. You put your polyethylene, right, to protect your steel from moisture as well, and also your slab. That's very important, right? And then you lay your rebar. You can also put your rebars are going, the rods are going up as well from that foundation slab, or you can later on, let's say, let me enter somebody here. Um, then you can later on, let's say, drill a hole and put those rod in. So it all depends what the engineer wants to do, right? But we prefer to do the later, right? To do, let's say, the drilling of the hole, put the epoxy and then the rebar. so that then you have straighter, let's say, rebars going up. But we'll go into details now on this. These rebars here on the right, you're going to see your foundation here, and probably the engineer is going to have that from the bottom of the foundation going up. Usually these pick up 18 inches over the slab, and but like what we say is that you can drill the holes later on and then stick the rebar down whatever inches, right? The epoxy permits, right? And then you stagger the rebar every let's say 8 inches, or you separate them on each side every 16 inches, right? So each side will have a line of rebar every 16 inches. So that's where you're going to place the panel that comes in 4 feet by the height of the wall, and you're already going to have your mesh. Then like in this area here on the left, you got to make sure that your finishes comply with where you're going to put your panel. Okay, keep on here. And mainly, I mean, our testing were done with 3/8 of an inch or rebars, number 3 rebars. So that can be used, or you can use 1/2 inch rebars here on to anchor the panels. Okay. Here are some examples of the foundations where this would be in the middle of the wall. So you do your regular calculation design. So how much actual wall you're going to have that in that wall, right? So you design your foundations with that, and then also if you're on the edge, then you also design your rebar for that foundation. Okay, that's just some examples there. So the first thing you do is you mark where you're going to put your walls, okay, with a chalk line, and then you drill the hole every 16 inches apart, and then you're going to make 2 lines staggered, right? They're going to be staggered in these rebars every 8 inches, but then they're going to be spaced out every 16 inches, like you see here. Okay. So more closer view here. We're going to have probably a door. So you already mark the where you want to put the edge of that let's say of that panel. Like the PSM 80 is like a 4-inch from rebar to rebar, so that means that you have to mark them at 4 inches spaced out, right? For the rebars from one side to the other. Okay, if that's the size of the panel, but these panels come from 10 inches to up, from 4 inches to up to 10 inches from wire to wire. Okay. And again, either you already have your rebars already set from your foundation, or you can drill them, as we prefer in our company to drill them afterwards, because then you can finish your concrete with no problems with any rebar going up. And also, if there's a problem with the pipes where they were located, let's say water pipes or any other pipe, you can also move that wall and place it where that pipe will be in the center. Okay. So once you place your panel, you have to, let's say, melt around the rebar and make sure you have like an inch. We use a heat gun for that, but you also want that rebar to be tied up with a tie wire to the mesh. So, but that the rebar is going to be inside inside the mesh. Okay, we don't want them outside the mesh. Okay, because that's the way they were tested in the field in the lab. So there are different ways to put these. I mean, the best way to start is by starting in a corner, right? You have your 4 feet panel, and then you'd be joining them one by one. One has a let's say a two square flat where they're going to be joining each other, and then that's where you're going to put the clips uh, on them to join them. Okay, so you can start let's say a room, and wherever it intersects, you'll finish that room, right? That's one way to do it, or you can do a whole wall and completely come and turn around and do that other wall as well. Um, but the main thing is you brace the wall so that it doesn't keep banging around with the wind, and it's also sturdier as well. So you see here, they square the room, and so now you have a sturdier, let's say, construction. So again, the second way to do it is, again, you can do one wall, then just use one panel, and then you just continue and then finish the other wall, and then you have a sturdier, let's say, wall to hold on. Okay, well, before you start using all the clips and angles, angular meshes as well, and all the corner meshes. Okay. So how do we cut these panels? One way to do it is you can use these pliers. I think that's one of the easiest way. They really cut well the wire. I mean, this is a high tensile strength galvanized steel, which is 95 KSI, and if you use, let's say, carbide or diamond disc, it's gonna be a little bit slower, and it's gonna take up more, let's say, disc on it. But I've seen people out there in the field also using the disc with it. But I think with the clip, you can do a better job as well. So once you mark it and then you start cutting that wire, then you can come in with your regular saw or miter saw, and you cut the foam on there. So you can cut, let's say, the windows or the openings, or if you just need a certain length, then just cut that, and then you just take it over to the building and just place it. Here, these guys are very aggressive. They took 3 panels, and you can see how light it is. But again, we like to put one panel at a time, and then secure them in place. Okay. Here you can see how they're joining and securing the panels so that they don't start moving. Okay. This is how you want to brace them, right? Um, Also, we want this very plumbed, right? 90 degrees. So you can either use wood or lolly columns like these, steel, right? And again, we want to do this because in one side of the other side of that building, we're going to start putting mortar. So we want that building to be sturdy, right? So it doesn't move on you, right? So again, this is how we put the bracing. We secure it to the slab, and again, we want a very plumbed, a 90 degrees wall, because again, if you don't have a 90 degrees wall, then you're going to use more mortar, finishing mortar to make that wall straight. So that's why we want that 90-degree wall with the floor, right? So you use a plumb or a level to do that, and whenever you're securing these the wood, right? You want to pass it all the way around that's to the other steel, right? Not to grab the first steel, but all the way through the wall, and then to the second steel. You want to hold that bracing. Okay. Sorry, going back here. Okay. So these are the clip machines that are used. We prefer the ones that are pneumatic, like the one here on the right, because it uses, let's say, a 90 psi compressor with air, and it's going to go real fast. So every 2 square, we're securing the walls, right? Or let's say the roof slabs as well. Okay. And again, these are galvanized clips. And so So it's easier to use, let's say, the pneumatic guns than the handgun. I mean, probably if you give a handgun to somebody like that, he'll probably last only 1 hour. But with the pneumatic gun, you're going to go faster, and it's going to be easier for the application. So here we're explaining how we join the building with these corner mesh, flat mesh, and U mesh. So this one here on the top left here is our corner mesh. They come in 7 inch by 7 inches, and they also come for the exterior of the corner. So the 7 inch by 7 inch, we put it in the interior of the corners, and or let's say in that corner of the wall, and then the 7 by 12 we put in the exterior, and I'll show you why we do that, because we want to pass, let's say, where we have joints, and we make sure that we have two squares to lock that mesh out. And also we have the U mesh. These U meshes are used around the perimeter of the windows and doors. Okay, that's where you're going to use them. And we also have flat mesh that are like 15 inches by 4 feet long. And also we have 4 by 4 foot meshes, and also 8 by 4 foot meshes. And I'll show you where we use those as well. So the angular meshes here, if you're joining, let's say, walls and roof, you're gonna be using these corner walls, 7 inches by 7 inches, right? The corner mesh. And also you'll be probably using a flat mesh, and then if you're joining another wall slab on the top here, that's where you would use a flat mesh. Okay. So again, if this is a floor slab, you're using your corner mesh underneath. Then also, let's say if this is a floor slab and a wall slab, this would be your interior corner, and this would be your exterior. Here you can see the joint, as I was talking to you about. So you needed the longer face here, the 12-inch face of that angle to be in that side, okay? And this is how we would see, let's say, a typical roof. Uh, Sometimes you have slopes, sometimes you don't have slopes. But you can design them either or, okay? So how do we reinforce, let's say, the perimeters of the windows and doors? So we use these flat mesh, and we cut the pieces. Let's say they come at 15 inches by 4 feet. We cut them in four, right? Right in half. So we have four pieces. So every flat mesh will cover one side. So for each window, you'll need two flat meshes that are 15 inches by 4 feet. And whenever you're doing your frame, right, for the window, or let's say the door, we ask that you measure, you have 4 inch more of distance, so that for that edge, so you can cover the edge of the window with warm water. Let's say 2 inches, or let's say from 2 inches, or 1 inch and a half on each side, right? So that's why we say we need 4 inch more of spacing, so that whenever you put your window and you use your screws, you have more, let's say, structural mortar to attach that window to. Okay. And this would be our PSG3 slab. Usually the PSGs are used on the roof whenever you want distance from, let's say, 12 feet to 32 feet, right? And they come in with, this is a PSG3 because they have three girders here, 1, 2, 3 girders. And here you deposit two number 4 rebar there on the bottom. And you also have to make sure it's not touching to the let's say the foam, right? So you have to put something underneath it as well. And so your roof is going to have 3/4 of an inch over the mesh with structural mortar. And then on the top of the roof, you're going to have regular 3,500 psi concrete, and that concrete is going to have fibers, and the let's say the aggregate is going to be like a half an inch down, right? So you just want half inch down of that, or smaller, let's say, of that aggregate. So these girders will vary from depending on the size, right? Again, you have a PSG 100 to PSG 200 to 240. Those are millimeters, right? 100 millimeters to 240 millimeters, right? Okay. So again, these are used in roof. You can also use the PSM, but again, the designer has to decide on the thickness and what let's say pounds per square foot that PSM panels will resist or not, or the span as well. And you have between rooms. So there you have to select either a PSM or a PSG depending on this on that span. So again, if the span is between 14 to 32 feet, you'll probably be using a PSG 2 or 3 or 6. So these comes in either two. You either have two girders, three girders, or six girders in 4 feet. Okay. And how do you tie those PSG to the edges? We call this a bond beam, okay? And then you put it an L shape here on with your rebar, and the rings spaced every so often there'll be a 3/8 inch rings with probably half-inch rebars going through here, and then wherever your girder was, you're going to have those L shapes going in, right? And then when you pour your concrete, everything's just going to be joined there with that with that slab. Okay. So here's a picture of how that looks. Here they added, let's say, cantilever about 2 feet, over the wall, right? And so you have here your you're practically doing let's say a beam here, um, and so you're reinforcing this. You're adding additional negative rebar so that you can have, let's say, an extension after your wall. Let's say a cantilever there, and that'll be your negative rebar there, and just to get an idea of how these structure are designed and they look, right. So here, see, you can here you can see how in the center you're going to have higher, let's say, thickness of concrete. And then to the edge is going to be 2 inches minimum. Okay, so probably in the center it'd be like 5 to 6 inches of concrete, right there in the center. So that's to make sure that you have a slopey, let's say, concrete, and then you don't have any ponding water. And I brought these pictures because you can also join steel frames, say columns, beams, joists as well, and also a complement with the panels. Let's say if you have a spacing about 40 feet, and our panels just gets to 32 feet, so you need to add additional beams and columns. Depending, you can also add those beams and columns with either concrete, or you can use additional panels, or our panels to do it, those columns or beams. Like here on the center, you can see this. There's the beam right here. How they shifted the panel to the side, and you can use it as a beam. Okay, but again, you can integrate steel beams and columns. You can use the steel beams and concrete. Here is also an idea of the design, how they did it here with the rebars and also the joist. Again, these panels are, you see how long they are. They are very light. I mean, they're very light to carry, and all you need is just panels. You don't really need additional beams or columns in there, or additional rebar. All depends on, again, of your design and how the structural engineer sees it as well, and whatever he says on that blueprint or specification, that's the way it's going to go, right? But again, you can do structures up to 4-story high with just these panels. Okay, this is showing how we do the supports whenever we're putting the, let's say, the panels on the roof. So every 4 feet, we're putting a 2x4 or 4x4, so that we can use, let's say, lolly columns, or we can also use wood to hold them. But again, if you have this is your long side of the panel, then you have to put these bracing transfers to the, or perpendicular to the length of that panel. Okay, and we usually start like 2 feet from the walls, and then every 4 feet you put one of these let's say bracing or supports. And here we're showing from top to left to bottom right. Um, this is how we're spraying the mortar inside of the building, right? You first put your first pour of mortar. You can also be shifting these to the side, so you can cover the area that you missed when you were spraying on that first, let's say, spray of that mortar. Okay, so you can move them. Right? And this is done before we let's say, pour any concrete on the top. So we don't want any weight yet on that slab. So how do we put our plumbing and electric on these panels? And first of all, we use a heat gun, and we melt for where we're going to put our electrical boxes and our pipes. Um, and then once you have that opening, right, you put your either, this could be PVC pipes or flexible pipes, um, and that's the way we want them. If you're using copper, you have to put a sleeve of, let's say, of a plastic pipe over it, because again, you don't want that copper to join with the other metals in this wall. Okay. Yeah. While we have in this picture, this is how we frame the let's say the doors. Okay, so you have that. Remember that 4 inches, or let's say 2 inches on each side. This is where we want more structural mortar going in. So once you have this framed up, and you spray your mortar, then you'll have that finished, let's say, door or window edges. Okay. So these are several heat guns that are out there. You can either buy a cheaper one that costs $40, or a brand made let's say, heat gun, which may cost $80. But again, the main thing is that they have like 500 to 1,000 degrees, so that they can melt that the foam. And we again, we prefer a heat gun like that instead of, let's say, torch, because the torch will burn through the foam and probably take more of that foam that you want. So all we need is just at least an inch around that, either the pipes or let's say the rebars or whatever. You don't want anything touching the foam except the mortar. Okay, that's why we want to separate with that heat gun, and all the pipes, and or steel, and that is out there. So here's a detail here where they put some structural mortar around the boxes, and that's wherever you need to level that box so that you have that finishing wall. That's where you have to place that box, and you can do that first with the structural mortar and put it in place first, before you start. Back here. So so once you have all your piping and everything, and all the angular meshes put, and all your U mesh put, then you're ready to, let's say, put some mortar. And what we do, we put some guides every 3 to 4 feet, right? These would be PVC pipes, 1/2 inch pipes. And these will be over, let's say, the steel mesh. And our specification require that you have like at least 3/4 of an inch of structural mortar or that steel. Okay, so the average between the foam and the outside of that mortar will be at least about an inch and a half almost. Okay. Um, so again, you separate those pipes every let's say 4.5 feet maybe or 3, depending on your screed, how long you have your screed and how high you want to put them, and that way you make sure that you have that 3/4 inch covered. So, and then you can, for the walls inside and out, you can just do that, the mortar in just one spot. Okay, and then you just have that finished. Okay. So here you can see a photo of how that looks. So get like let's say every 4 feet, and then you come in with your screed, and you fill everything up from your foam all the way up to where the edge of that screed, let's say pipe is. Okay, so that's where you're going to have the 3/4 inch over the structural mortar. And again, you once you start spraying, then you're going to be doing, let's say, lines from left to right, so that you have a mechanical bond, so that when you're ready to, let's say, put a finished product on there, like 3/4 of an inch finished mortar, you don't need any bonding agent. Or if you're using, let's say, a synthetic stucco over a structural mortar, you can also do that. Or if you're using another finishing like aluminum siding, then you just leave it like that and just cover the building with it. Okay, so you can also do the spray. Again, here you can see a picture of how that looks. You start, you can do like a skim coat first over the foam, and then you just build up to the mesh, and then once that's ready, you can put your guides and then cover the 3/4 of an inch mortar. Okay, so here's step by step how they did it, right? So they started their mortar on the outside. They started, finishing the structural mortar, and they left the lines there from left to right with a 1/4 inch by 1/4 inch trowel. Then they came in with a finished mortar and they finished it. And so they come, you see the final product, right? Nice and beautiful painted, very nice and square. And these are the products that we manufacture. We have the structural mortar 4000. That's the first mortar that you're going to be applying. And then we also have this the type end, where that one's just for finishing. You can use the up to, let's say, a 3/8 of an inch, half inch, depending on how good you squared out that wall, right? Or again, you can either use other finishes as well. So to review that, right? So again, we need to cover over the mesh 3/4 of an inch of structural mortar, right? Now, again, we're going to use the guides at least half inch, right, diameter to get that 3/4 of an inch. Then you mechanically go from left to right with that trowel, 1/4 inch by 1/4 inch, and then you come in with your finished mortar and you finish. Okay, let's to summarize that again. We represent MTech in the U.S., in Puerto Rico, in the Caribbean as well, and we sell these machines. This is the Monomix. Mainly the Monomix are used in our projects because they're like 240 volts, and so they're 30 amps, so that can be found in any building. Or if you don't have electricity, then you need like a 10 kilowatt, let's say, plant or generator to move it. Also, you need at least 40 pounds of water to operate this machine. So this machine, what you do is you put the bags over, and it has a cutting edge on the top, and it'll open the bag, and then it'll mix it in here, uh, and while it turns, it goes through the sleeve, which also has a rotor in there as well, and then we'll join that to a 32-foot hose, and then you have a gun on the front which will spray the mortar. Okay. Then the dual mix, we usually use it with silos or bigger buildings, but it's very, very efficient. But again, this is a three-phase uh, uh, three-phase let's say electric a machine. So it's hard to get those the three phases, but then you need a bigger generator to move it as well. Okay. But again, we either we sell these, and so you can call us for prices, and we will quote you on those machines as well. And our products are designed to work with this machine. And again, you don't have piles of sand, piles of cement, laying around. Because all you just need is just these bags, and we have designed them with let's say fiber and admixtures that will help you with finish these projects faster. So imagine you can do 300 bags in a day at an inch and a half, let's say. So your productivity will be very, very fast. Here we're showing you that on the roof it can either be flat or let's say with a slope. And wherever you have a flat roof, by code, every foot you need to go up by at least a quarter inch. Okay, so that means that at the edge you'll have minimum 2 inches, and at the center you'll probably have five inches of concrete. Right? So you have a slopey, let's say, surface. Okay, so that way you don't have any ponding water. But if you have a very slopey roof, then all you need on the top is 2 inches, and on the bottom is 2 inches minimum of concrete over the steel mesh. Okay, and again you can go over the panels again, making sure that they are braced underneath, right, and and it has the proper support to go over it, or you can lay wood over it just to make sure you don't damage it. But again, they're very sturdy while you walk on it. And again, these are the way we're fastening. I mean, you can fasten these if you're putting, let's say, a nail screws to do some supporting, right? You can use top guns, top screws, and top gun screws to penetrate these walls. Again, this mortar is 4,000 psi, so but we don't recommend you bang in, let's say, with a let's say with a hammer and a nail. You shouldn't be doing that. You use a drill, and then put these um, these screws in. Okay, that's the way you fasten either. I mean, whatever you need to fasten to the walls or roof. So again, we covered most of the let's say the material. I think I took a little bit more time than I expected. Now I wanted to show you some projects, but I want to hear some questions from you guys first, and then we'll if we have time we'll see some of the projects we have done so far. Right now we're open for any questions that you may have. So these are some of the projects we have done. So you get some ideas of projects, right? Done chilies. These walls about 18 foot high. See there, we can they joined also with joists that's here as well as chilies. There's a this is the silo we were talking about with the Dualmix, where you have higher buildings, then you can use a more efficient machine as well. And you've done industrial buildings, regular buildings like that, small ones. This is a school we're doing right now, and you can see here the panels, how they support them again, and how they came in. So this project is under construction right now. You can do several housing projects with slope or no slope on it. Here you can see the cantilever here with the panels only, because that was like 10 foot. Sorry, I missed it. Okay. There you go. And yeah, we had a 6 point something earthquake here in Puerto Rico, and no damages were done to this building, but other structures that suffered, a lot of cracks, and so even some schools came down and crumbled. But again, these buildings will withstand allow, let's say, seismic movements. So they look like structures. Again, you can either do rounded as well. You got that versatility to do that. Nice, beautiful home there, modern. This is in Florida. See, over here they use the walls with the without panels, and then they used a wooden roof on top here. Right.
Have you done something in the Caribbean so far?
Here's what we can do. Again, see the beams on the top, and these are our columns with the same material of our panels. So you can do that as well. You got a 2-story building here with the panels. So this whole structure was made with our panels, even the roof. Okay.
Can you hear me?
Beautiful here. Again, they wanted to do a steel deck next to our panel building, so they joined with steel beams this area here. It's a warehouse. Okay, and then there's around the world they've done so many jobs. It's been incredible, like in Antarctica, to lower the cold inside these buildings. I mean, you can do that as well. Look at this in Colombia. This amazing design. Look at that with no column in the center. But it's a beautiful structure design there. I like that. And or you go to the extremist area in Africa where it's very hot. And then now the building is going to be very cool inside. So your AC is going to run more efficient. Again, you can use these as curtain walls as well, and use steel beams, and also to help out in the building, although it depends on the design, right? There's another office building. So yeah, here on the left, all this was done with just panels. So if you have any questions or in the future, or if you need any quote, or let's say any help with the design of these system, you can call us. Scott Miller is our technician up in Florida. He's he can help you out with the quote as well. In the US, I'm Ismael Vasquez, and I'm in with the engineering team with Victor Camacho, and we can help you out with the any questions on the design as well, and also quotes as well. Here are our local phone numbers, and Victor, do you have any questions, or we're okay?
We're okay. We really appreciate all the people taking the time for these webinars. Sorry that we had a little bit inconvenience with the internet, the slow internet. Some people couldn't connect. Next time we're gonna make sure that doesn't happen. But,
are you able to hear me?
Yes.
Hello?
Yeah, now I can hear you. Sorry.
Robles, JJ Trading in Puerto Rico, once brother.
Okay. Hi. Nice
Question,
to hear
is
you.
this video is going to be available?
Yeah, yes, it's going to be available in YouTube and in our sites as well.
Okay. Yeah, because I've been traveling the Caribbean for many years now, and I've seen this kind of stuff before, especially developed in the
The system?
UK. Yeah, maybe not the same thing. I, I mean, I'm not an expert on this. I'm more on the side on the side.
Okay,
But
good. Oh, nice,
I'm just
nice.
wondering
Yeah.
because and next question: have you done anything out there on the islands so far?
Yeah, we have done, other than Puerto Rico, we've done work in St. Thomas, St. Croix, yeah, yeah, other islands as well. And Vieques, Culebras, that's part of Puerto Rico, but right now we're doing two homes in Vieques. Yeah.
Okay. No. I mean, I just wonder because I really like the concept. I mean, it's amazing. And I know I've seen a lot of stuff like this. Whoever it is doing stuff in like in Africa and building like millions of houses over there and stuff like that. And but I mean, just wondering, just learning. That's why I'm here.
Good. Yeah, that's great. Great to have you. Sure. And if you have any additional question or you have a job or something that you want to do or design, let us know and we can help you out with that.
Okay. I know how to contact you, so I'm okay.
Okay, good.
Thank you. It's really nice.
Okay. Any other questions that you may have? John, Ricardo, Ana? See you on the line there. Okay. Okay. If we don't have any more questions, I think we're good for today. I really appreciate your time, and yes, we're going to have this recording in Facebook and also in our sites and in YouTube as well. So take care, and I'm glad you stayed with us all this time, and appreciate it. Have a great day. Bye-bye.